Alrighty. Um, yeah, so we're gonna talk about Django associations today, and kind of like what I was just saying. When you have raw SQL, you just create a table, and then you create another table, and you can connect those, right? You can use. I'll just add a foreign key to this table, and it will connect to the other table. So you're basically you're telling you're making that clear in your schema that hey, these two tables are actually connected. They're not just two totally independent entities. Um, with Django, you can do the same thing, but you have to follow their API. So if you understand the general concept, which you should, because we've done SQL, and I think everyone seems to get the basic idea. We just the problem now is how do we translate the knowledge of what we want the end state to be? How do we use this specific tool to get there? So associations, part of the problem is the tooling, and part of the problem is the naming conventions. So they don't say schema relationships; they say associations. So that's Django terminology. All right. So what I want to do is I'm going to clone down this example application, and we'll kind of talk about the structure. We'll review what everything looks like, and then we'll show an example. All right, so I'm going to go here. So I'll go to the main branch here, and I'm gonna get ready to clone this down. A little bit. All right, so I'm on my desktop now. I'm gonna clone this down. So git clone cd and go and open this. Okay, so clone down this repo, and now the question is basically I have a whole bunch of stuff going on now. I have this folder with a bunch of stuff in it, this folder with a bunch of stuff in it, and then I've got some other things at the top level. So let's look at this first. So what is this? Let me pick on someone. Eden. So what is this Docker compose.yml file?
I can like break it down. I know like when it comes to like the environment, it's just telling you like the user and the password and the type of database that you're accessing. And
Okay.
it's telling you the ports that you'll be connecting or it will be connected to. Um, volumes, I can't remember what that is. And I know like when version, that's the version that it is. And so if I can like put it all into one thing, I'm guessing that is what you are building up.
Okay, good. Yeah. Yeah. So what is this describing? Like this whole thing. What is the purpose of this all of this description?
To build a database?
Yes, yeah, exactly. So it's to build a Docker container with all this stuff in it. So it'll be a Postgres container. So we're describing all of the configuration that we want to go into this Postgres container. And what is this .yml?
YAML?
Yeah. So
I
can you tell me about some of the features of YAML?
um YAML. Can I get a hint? Because I can't remember.
Sure. So so how is this? So let's say if you were to compare a YAML file to a JSON file.
Is it to like configure?
Yep. Yeah. So if this were in JSON, so we could communicate this same information using JSON. So we could do something like, okay, we have we have an object, and the first key is version, and that is going to be 3. And then we have services, and it looks like that is going to be another object, and that object has a top level key called maybe this would be called DB or something. Services would probably be a list actually, but we'll just skip that for now. And then this would have another object, and this would be image, and then we have the value here of Postgres, and so on. So we could communicate the same information using JSON, but this is the way YAML works. So YAML is just another file format. So there are conventions and rules and how it works, and it's just another way of trying to communicate information. So I like to think of YAML as like the Python of JSON, whereas JSON uses brackets and so on. YAML basically uses spaces or indentation. So like Python, it uses white space to communicate about structure. Okay, so that's YAML. About the volumes, let me ask Sandy, can you tell me about what a volume is? Right, let me ask.
Sorry,
Oh,
I was
sure, yeah.
talking. Um, is it just indicating the path of the directory?
Yeah, yeah. So can you tell me maybe at like a slightly higher level, like what, why would we have a volume?
Um, I guess just to say, hey, like this is where I want this application to be stored.
Okay, yeah, it definitely involves like storing information or persisting information, and it could be about the application. But this, so a volume is basically a mapping from the container that you want to run to the host machine's file system. So usually a container is going to be completely ephemeral. So if you spin up a container and you modify a file and you save it and you run it in your container and then you spin down the container, that's gone. Whatever modification that you've done is gone. So if you spin up the container again, you're going to start fresh. So there are cases where you want to be able to spin up and down a container and actually save some information in between those sessions. And a volume allows you to do that. So if you have a database, you want to actually save the data, right? You want to save the data so that you can spin up your database and it can actually save data, like physically save the data in the tables. And you could spin down the database and maybe like upgrade the version of Postgres or something and spin it back up, and it should still have access to that same raw data. So a volume allows you to map. There are different kinds of volumes, in Docker. This is called a named volume, and basically you just say, hey, whatever, wherever you actually put this, like physically on my computer, I don't care. I'm gonna let Docker manage that. I'm just gonna give it a name so that I can reference it elsewhere. And then this is the path inside of the container. So when the container spins up, it's going to basically say, okay, my var lib PostgreSQL data is not really mine. It's really the host machines. So I'm going to reach out and create a connection to some actual directory on the host machine somewhere, and I'm going to use that. So it's similar to port mapping. It just allows a connection between the container and the host machine. Okay. All right, what about the requirements? Anyone want to tell me about the requirements?
It's all the pip installs that you have for the virtual machine you're using or virtual environment.
Yeah, exactly. So this is just a listing of all the third-party dependencies that I need, and in this case, like the exact versions that we require. So there are other ways of managing dependencies. This is kind of the simplest and most basic, which will, should work for 99% of cases. Okay. All right. So let's go ahead and I'm going to spin this up. So how do I execute this Docker compose?
Docker compose up.
Okay. So I do Docker compose up, and because we've named this file according to the conventions that Docker compose expects, namely docker-compose.yaml, it will automatically find that file and use that one. You can give these other names, and if you do, you just have to tell it, hey, I gave this file a different name. That's fine. So we can spin it up. We can also spin it up in -D. So this will spin it up in detached mode. Okay. So that should be running now. If I do Docker PS, I have this container spinning up. So now I have a database running, and I can see that the port mapping is there. So it used this file. It mapped 5454 on my host machine to 5432 inside the container. There should be a volume, so I can do Docker volume ls. Yeah, so I have, let's see, this should be called DRF wine API. Yeah, I think it's, should be this one, but yeah, so I have the volume up now, and I have a container, and I should be able to use this normally. So I'm going to spin this down now. And to do that, you just do Docker compose down, and as long as you're at the same level as this Docker compose file, it'll automatically read in that, and then it'll spin down all of the resources associated with this YAML file. So it's convenient, even if you just have one service, i.e. one container. It's convenient because you don't have to go in and manually stop all the other containers that you have. You have it in one place, you run it, and then you stop it. Okay. And then the Pokemon app itself. So what's the difference between in Django a project and an app?
An app is like I'm having a blank here. 1 second.
Yeah.
An app is it'll contain like the database or maybe some other stuff that you need it to do, and a project just contains multiple apps, I think.
Yeah. So exactly. So a project is like the top level entity for a given Django thing. So it's a top level thing. We'll see. We're not worrying about URLs right now, but once we get into actually the views and other things like that, we'll see how the URLs comes into play. And there's also settings. So these are like the global application, anything that you want globally available, basically. And then the app, you can have multiple apps. You can have lots of different apps. So these are like specific components of your web application. So if you imagine, you're doing like Amazon or something, if you were to create, Amazon using Django, you would have different apps for like user authentication and maybe like a bookstore and maybe like an ordering or maybe a shopping cart app. Or so you could have all these different apps for specific components. And it's a little squishy. So, what exactly is an app? Should you break this up into multiple apps or not? There's definitely some judgment calls that you will have to make. Just like if you write a function, like when do you know that this function should actually be two functions? Is there? Yeah, you just have to get a feel for it. Okay. And then, so within this app, we have the models. So we have, for right now, we have this one model. And what is this class going to translate to?
Table in SQL.
Yeah, exactly. So we're writing this as a class, a Python class, but it's actually going to become a table called Pokemon, and then it's going to have these different columns. So we define all the columns here, and then we give the type just like in SQL, right? So any questions about that?
Yeah, I have one. You
Sure.
talked about breaking the apps down like functions. How then would they talk to each other? Is
Yeah.
it the same like a function?
You can, it would be like writing, having one big function and then breaking it up and putting it into two different files, and you could import one to use the other. So you'll do the same thing. So if you have multiple apps and you want to share something or use something, for example, we'll do that today, where we're going to create another table in another app, and those tables need to talk to each other. So we'll just import it. All right, so we've got that going. So let's go ahead and we're going to create a new app here. All right, so and the command for that, so Python manage.py. So manage.py will handle like different kinds of scripts. And so there are, basically a whole bunch of commands like Django commands or scripts that you can run. So you'll invoke manage.py and you'll pass in some arguments to manage.py, and there's one available called start app, and what it will do is create an app for you. So let's go ahead and run that. Okay, so I have an error here. It says import error, couldn't import Django. So why can't I import Django?
Because you're not in the virtual machine or
Yeah,
virtual environment.
yeah, exactly. So I don't have it installed. If maybe by chance I had mistakenly installed Django globally on my computer, then I would be able to do that. But I haven't done that, so there is no Django. I haven't installed it. So I need.
Sorry, I have a quick question about this. So when I was working on this on Thursday, I accidentally installed Django globally, and I could run everything without I could only run my stuff outside of the virtual environment. If I tried to go inside the virtual environment, I would get this error.
Okay.
And then I even tried to uninstall Django and like reinstall within the virtual environment, but I would still get the same error.
Okay, yeah, I can take a look. But basically, yeah, if you install it globally, it'll be available globally. If you go into if you create a virtual environment and then install all the requirements, what's in the virtual environment should override what you have available globally. But yeah, I can take a look at your case. Sometimes, yeah, things get a little mixed up. But yeah, that's how it should work. Okay, so I'm gonna do Python -m then, and I need to actually activate it. So source bin activate. So now I am inside of my virtual environment. So now I can install the requirements pip install -r requirements.txt. Okay, so now I should be able to run like a command like pip list, and I should see Django. So I'm inside of my virtual environment. I run pip list, which will tell me all of the pip packages that I have, and I see that it's there. There's also like pip itself and setup tools, which you don't need to worry about. It just kind of comes automatically. But everything else is there. I can compare that with my requirements file and see that all this stuff is there. All right, so now I can actually run the Django command manage.py start app. So I ran the command, and Django basically just created its default setup for an app. So it created a directory. I have all these files in there, and another migrations folder. So that's it. So, you know, if you wanted to by hand go in and do this manually, create a folder called move app, and then create all these files in here and so on, you could absolutely do that. This is just a convenience. All right. So once we have a new app, we basically have to tell the application that it exists. So this is just how Django works. So there's this installed apps in the settings. So we go to the project and the settings, and we can just paste that in there. So now the top level Django entity will know about this app we've just added. And just to take a look here, so we have this database configuration. So if you create a new project from scratch with Django, by default, you're going to get a SQLite database, which is like a file-based database, just one file. But we're going to use Postgres, and we're going to pass it some configuration. And the only thing you really need to worry about or make sure of is that it matches what you have here. So if we're running Django locally, so we're not running it inside of a container, we're just running it on our host machine, then we need to make sure that we can access that. So 5454, that matches. And then the credentials here, username and password, user and password. Later on, we'll talk about how we can manage sensitive credentials better rather than just hard coding them here, but it's fine for now. Right? So as long as all the configuration matches what our actual database is going to be, then we're good. All right. So I'm going to go over here and add this. I'm going to go to move app models, and we're going to create a new model, so a new database table. Okay. So this database table is just called move. It's got some features, and then we've got some additional methods that we can override. So we're overriding the built-in string representation. This can be handy when you're debugging. So if, for example, if you don't do this, you're going to get a very generic description. So this, you don't have to do this, but it just makes it a little easier when you're debugging stuff. And then we have a couple other methods that we can call. So for example, increase max PP. all this is going to do is grab it, and we can treat this like a normal Python class. So we're just going to grab the value and then increment it and then save the row again. All right, and we'll add this other validation thing. So remove app validators, which we're gonna have to create. So by default, we're not gonna get a validators file, so we'll create that validators.py. So we're importing that here. Now we can actually use that. Okay, and we now have changed our database. So anytime you change the actual structure of the tables, or you add a column or something, you have to run migrations. And can anyone tell me what a migration is?
It moves the class or whatever else you did to the database, the Dockerized container or something.
Yeah, basically, yeah. So what it does is it will allow you to make updates or changes to your database schema. So, when you first develop an application, you think real hard about it, and you come up with a data model, and then you implement that in SQL, and you have all the tables, and you're like, okay, great, this is working. But then, a few weeks or months or whatever later, you realize, actually, I think this move table, it really should have another column, because I want to add a new feature to my application, and move needs to have another column or something. So to do that, you could potentially just go into the database directly and then just say, alter table, move, add column, whatever. But if you do that, there's basically no record of that happening. So if you have a complicated application, like any application is going to end up being, and lots of people are making lots of changes, it's very easy to get to a place where your database, like, basically nobody knows what's going on in the database. It's just like Wild West, people making changes. Some changes are breaking the other things, and so on and so forth. So if you have a migration strategy that it allows you to record, like, the state. You're basically keeping a record of every change that you've ever done to the database. And you can basically replay all of those changes and make sure that all of them work. So it's basically giving you a history of every change that you've made to your database, so that you can replay it, and you can also go back to a previous state of the database. So if I have, I have this application that's been around for years, I've made, hundreds of changes, and then one day I make a change and it doesn't work, it breaks something, I can roll back to the previous version. So it's basically just a way to manage complexity. All right, so I'm gonna run this migration. So first you have to do this two-step process. One is make migrations. Okay, so I have an issue here, blah, 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 runtime warning. So what happened is that, can anyone guess what the problem is?
You didn't start the database?
Exactly, yeah. So I started it and then stopped it. So there is no database running. So I have this issue. So I'm going to actually start the database, and I'll just do docker compose up -d. So that should be running now. And now I'm going to try to rerun the migrations. And so the first step that you run So I ran migration. So I have two models here. The first one is this, and you should really never need to do this, but just to let you know, this is like a slightly lower level representation of the model. So we have just, well, we'll look at move for now. We have move, and here's the like Django code that you write, right? So this describes the move table that you want to have. And then this migration is just a little less user friendly, a little lower level representation of that exact same model. So this intermediary representation of your model, you can save and check in, right? So you can check this in as part of your code, and you can go in and see like, here are all of the migrations that have ever run. So this is a lower level representation that Django manages, so you should really not need to go in here and do anything with it, but that's why it's there. So now I can check this in, and there's a record of all the migrations that I have. Now to actually execute this, to actually make the change in the database. So before we do that, I'm going to go into the database and see what tables I have. So I'm going to do psql localhost -p 5454. I have to use the host port mapping, and then -u Postgres, that's the user. The password is also Postgres, I believe. And if I describe everything, there are no relations, so no tables in here. So we have the database spun up. It's just a fresh generic database. It hasn't been touched yet. We've now run the make migrations command, which is going to get everything ready. And then once I actually execute it, so let's see what happens when I actually execute it. So that'll be migrate. This will actually change the database. So there's a whole bunch of things, especially the first time you run it, you're going to get a whole bunch of output. And almost all of this is internal Django stuff. So again, this is a framework. So Django gives you a whole bunch of stuff for free. So it gives you a user model. There's like an authentication thing, and all of this stuff has its own tables. So Django gives you a whole bunch of stuff, and a lot of that stuff needs to persist data. So it creates its own database tables. You don't need to worry about that. What you need to worry about is what you made, which is right here, the Move app and the Pokemon app. So now if we go in here, I'm going to check the database. It's Pokedex DB. So I'm going to exit this. And I'm going to connect to Pokedex DB. And if I describe everything, I can see that I have all of these tables. So this is Django magic stuff. So Django created this table called auth group permissions, auth permission, auth user, et cetera, et cetera, et cetera. And then down here are the tables that we created. So move app move. So notice that we didn't name this table move app move. We just called it move, right? We called it move, and we can refer to it as move throughout our application. But under the hood, Django, when it actually goes from the code that you wrote to the actual database implementation, it does some stuff. So you should really not need to do this. I'm just kind of showing you. I'm trying to demystify this a little bit. So I can treat this like a normal table now. So I can do select star from move app move. And I can see that I have ID, name, accuracy, max PP, blah, 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 which is the same field. So Django will automatically give you an ID field by default. which will be in like a serial auto incrementing integer. But we have name, accuracy, max PP, PP, and power. So Django created this table. I could do the same thing with Pokemon app Pokemon. Notice that it takes the name of the application. So move underscore app, and then just appends that to the name of the model. So Pokemon app underscore model. So that's just the convention that Django uses. But we've gone from this very high level, Python friendly representation to an actual database models. Okay. So we've done that now. So we'll go ahead and write a test to make sure that this does what we expect. We'll go to move app test, and we'll just create a basic test. This is basically just testing the validators. And we can run the tests here by doing Python manage.py test. And it will automatically find all of the tests that you have. So anything that you have in test.py, it will automatically find all that stuff and execute all of those tests. And if you see this output, it should look familiar because the Django testing framework is just a wrapper around the built-in unit test module. So we can go here. Let's see if we can jump into the source code here. We have test case. So we're now in the Django source code. So we jumped from, okay, we're just going to import it and use it. We don't really care how it's implemented, but now we're curious. So we go in here, and then this inherits from transaction test case. So we can take a look at that now. So transaction test case gives you a bunch of stuff, and it will inherit from simple test case. And then ultimately it inherits from the thing that we're familiar with, which is unit test.test case. So the Django, built-in testing library is just a specialization with Django, with additional features that are useful for Django in particular. But yeah, that's what that's doing. So we've got, if you go up the chain of inheritance, you'll ultimately reach the built-in unit test case. So that's why the output looks like this. All right. Questions about that?
Can you make migrations or migrate only from one app if you want to, if you have like multiple apps?
That's a good question. I would think that I haven't actually tried to do that, but let's see what the documentation says. This is pretty old, so I think Django's been around for a while. So you gotta watch out for that. Maybe something from 2022. Let's see. So it looks like you can specify something like this. I could try it real quick, running a specific migration. Yeah, so let me just execute something like this and see if it works. We've already run the migration, but we should get a message. So Python manage.py migrate. Yeah, so it looks like if you pass in the app, it will just run that one. Okay. All right. So now we have a model. We can go into the database directly and see that it exists and it looks, it looks correct. And we have a test, which will make sure that, we can't give it invalid data, for example. So now we can actually go in and start playing around with stuff. So I'm gonna manage.py shell. So this will, I'll do it from here, I guess. So now I'm basically inside of a Python interpreter, and I can import stuff from the Django app, and I can play around with it. So from move app.models, import moves. So we're going to import the model, and then we're going to create a row, basically create an instance of the model, which is going to be a row in the database table, and then we'll save it and then exit. Okay, so we've just done that. So if we go now to the database directly, so we created a move, so we should have a row in the move table. So let's see if that actually shows up. So if I do select star from move, yeah, I can now see that we have this row there. So again, Django gave us this ID column by default. That's a setting you can override. But so that's an example of using a tool like this. It kind of assumes that you want to have an ID column. If you don't, then you have to do a little bit of work to make it not give you that. But yeah. So this looks like what we would expect. All right. So we're going to do now, and we could also go in here. So instead of querying the table directly with SQL, we can also use the Python API to get that same information. So I'll go back into the shell, and I'll import this model. Get that key. There we go. Okay, so I've imported move, and now if I want to get, let's say, I want to do the equivalent of select star from move. You do move dot objects dot all, and it gives you all of the rows. So this looks obviously a little different than this, but it's basically the same information. So the Django ORM has actually formulated a query which should be this essentially. So I can't see what the actual query is, but it is almost certainly this or something very close to this. And then it takes all of the data that it gets from the database and serializes it, basically takes that, those bytes that it gets and turns it into the appropriate Python objects. And it gives you something called a query set, which is basically just a list. So we have a list of rows. So we could do something like we'll get move.objects.all, and we'll get the first row. So we've basically like grabbed the first element in this list, query set list. And we could also, because it's now Python code, we can access it by, let's say, dot accuracy. And we get 70 there. So yeah, again, we could do the same thing here. We could do select star from move app, limit 1, and that, or select accuracy from move app, move limit 1, or something like that. So that would be the equivalent query to what we just did right here.
I have a question real quick.
Yeah.
So you entered the shell and you created a move. The move name was just psychic, but how did it, I might have missed it, but where did it get the fields for accuracy, power, and current PP?
Yeah. So that's a great question. And it's basically how we've defined this field. So we have models.positive integer field. So this is just a specific Django thing that's going to make sure that you have a positive integer. So it's going to be an integer, but not a negative one. And default here. So the default is 70. And if we look at the migrations here, there's accuracy. So yeah, I don't know if there's a way. Let me see. So there are some constraints here on the actual table. So some of this validation is just going to happen at the like Django layer, and some of it is going to be actually recorded as part of the database. So here are some constraints. So there's this accuracy check. So accuracy has to be greater than or equal to 0. And that's basically what this positive integer field is doing. So again, this is built-in Django code that is ultimately just going to do this. So it's just adding a constraint to the table. And I don't see the default stuff, but that's the basic idea here. So it looks like the default stuff is being handled on the Django end. So if you don't, basically like a default parameter. So if you don't pass in a value here, it will just use 70.
Okay, yeah, that makes more sense. Thanks.
Okay, so now we have two independent tables, right? We have a moves table, we have a Pokemon table, but we actually want them to be connected. So a Pokemon should have, lots of moves, and a move could belong to many Pokemon. So we have a many-to-many relationship. So if we wanted to go into our database manually and create this table or create this relationship, how would we do it?
Just like doing the referencing, is that what you mean?
Yeah, so if you want to, so let's say, I have a moves table and a Pokemon table, and I want to create a many-to-many relationship between those tables. How do I do that?
Yeah, you get making the join table, so and then just having each reference it. So maybe like a table called Pokemon moves or something.
Yeah, exactly. So we in SQL, you can't directly represent that relationship, so you have to create this intermediary table, a join table, or a third table, whatever you want to call it, and then those other two tables have to be connected in a standard one-to-many relationship there. All right, so let's take a 10-minute break, and we'll come back and we'll see how we can implement this in Django. All right. So we're at the point now where we know what the end state is going to look like, what we want it to look like. So we have a Pokemon and a move, and we want them to have a many-to-many relationship. So that we know in SQL that we have to create a third table. But so that doesn't necessarily translate directly to what we have to do in the Django code. So we actually could create a third, an actual third model and call it, Pokemon moves or something like that. Or we can let Django handle that, and we can use, some higher level abstraction that Django will give us. So that's what we're gonna do now. And this is all stuff you have to look at the docs. So Django. You look at the documentation, which is pretty good. And it tells you blah, blah, blah. So the example that they give is an article and a publication. So, an article can be published in lots of different places. Publication can have lots of different articles. And it tells you a little bit about some of the methods and stuff. So, if you actually wanted to do this, you would have to read through that documentation. But once you know kind of what you want to happen, it's a lot easier to go through, and then you're just focused on like, how do I make this happen using this specific code base? Okay. All right, so let's go back to the README. So we're gonna go into the Pokemon and we're gonna add this onto the Pokemon. It actually doesn't matter which one you choose, but you don't do both. So you pick one of the models and have that own the many-to-many field here. So I'm going to go into Pokemon and add this. Whatever that is, Pokemon app models. So we'll just add that right here, and they have to do some imports. And then we're going to add another validation method to make sure that we can't have more than 4 moves. Okay. All right, so we've just modified our model. So what do we have to do?
Make migrations.
Yeah. So we'll do that. So Python manage.py make migrations. Okay, we have another migration here, and we can see we're adding a field called moves, and it's a many-to-many field, and it's connected to move app. So again, you don't really need to look at those migration files, but just to show you, and then to actually implement that now, we're going to do migrate. Okay, so I didn't get any errors there, so it worked. So let's go into the database now, and let's describe the tables. So we knew that before we have this move table, and we have the Pokemon table, and now we have this Pokemon app Pokemon moves table. So we get this third table now. So even though we didn't create a third model, Django created a third table for us, and we can see what that has. I can do select star from, and again, because Django is kind of doing the bare minimum default stuff. If you want to have a more robust or customized join table, you can definitely do that. You'll just have to actually implement it yourself. But if you use this many-to-many field thing, this is what it'll do by default. So we have an ID, which is just like a reference to the the own table, like its own self. And then we have Pokemon ID, which is actually going to be a foreign key to the Pokemon.id, and then move ID, which will be a foreign key to move.id. Okay, so we have that third table there. So now we've done the migrations. So now what we can do is we can create some moves, and we'll see what that looks like. So I'm going to go into the shell again and do some imports. All right, so we should be able to still see, we should have the one Pokemon, so let's just check if we have any Pokemon available. So that'll be Pokemon.objects.all. Okay, so we don't have any Pokemon there, and then we have any moves, so move.object.all. Okay, so we have a move, but no Pokemon right now. So we will create a Pokemon. Let's see. Okay, so I have an error here. I must have missed something here. Oh, geez. You know what happened? I don't think I checked out the correct branch. Yeah, so I'm on the main branch. I should be on the day 3 branch. So I'm gonna check out. Sorry about that. So it's like nothing that I've talked about should be fundamentally different. I'll just have to. I'm gonna go back real quick and redo all of this stuff. But you know, all of the fundamental things we've talked about so far are the same. Just let me. I'm gonna go ahead and I'm just gonna undo all of these. And so I'll see git branch -a. So I want to check out this. So git checkout. Okay. So I should have the correct branch checked out now. So I'm going to go ahead and also, I'm going to spin down the database. So I'll do Docker compose down, and I'm going to pass in the -v flag, which will also remove the volume. So it will be possible to keep this, or you know, but I might get a migration conflict, which I don't want to deal with right now. So I'm just going to remove the volume and start fresh. Okay, and then I'm going to spin it up again. So Docker compose up -d. Okay, and I'm just going to go through real quick with apologies and run through this again. See that that is already there, so I'm going to delete this. Let me just check the settings to make sure. Okay, cool. I'm going to add move app. App models.py. Validators. I'll just skip the migrations. We're going to change that again anyway. Tests. Skip that. We'll modify models Pokemon. We'll go to Pokemon models and this field. Let's do okay, so now we can run migrations. All right, let me actually exit. That and okay, so we'll go into the shell and we do this again. So I'm gonna go ahead and create a move and a Pokemon. And I'll create another Pokemon. Apologies, Pokemon experts. Okay, so I've got two moves and now I can create a Pokemon. Okay, that actually works. So I can, I'll check now. So move dot objects dot all. Okay, I've got the two moves there, and I can do Pokemon dot objects dot all. All right. All right, so now what I want to do is I want to associate these two independent things. So I can grab each Pokemon, or I can, grab a specific Pokemon using the ID, and I'm going to also grab a specific move using the ID. I could also do M2 equals move dot objects dot get ID equals 2. All right, and then how do I connect them? Well, basically use this. So Pokemon1 dot moves. So you see here, let's see, where's the Pokemon model? So just like a normal Python class, I have a class and then I want to access a field on that class. So you just do dot, whatever the field is. So dot name. In this case, we have a field called moves, which makes sense, right? So we can go from Pokemon and we can get moves. Question is, if we're on move, can we get to Pokemon? So it's not obvious from looking at the code that there's a way to do that. Django actually does give you a way to do that. It's just not quite so direct. So we'll focus on the obvious way to do it. So we can go from Pokemon to moves. So we can use this add. So Pokemon.moves.add. And if we check now, let's do Pokemon1.moves. We get this manager object, and we can use the manager object to call normal methods like all. So we can do moves.all. And this gives us all of the moves that belong to Pokemon1. So Pokemon1.moves which is going to be another field. So just like you do, moves.objects.all, it's basically Pokemon1.moves.objects.all. That's essentially what this is doing. So we can grab all those, and now we can add another move. So Pokemon1. So instead of adding moves1, we'll add M2. And now if we try to get all of Pokemon 1's moves, there are now 2 moves. And we could go check that in the database. So you see all the tables. So how would we, I mean, this will be kind of ugly in the terminal here, but how would we get all of Pokemon 1's moves?
Yeah, I'm just thinking in my head, it's gonna be a long join statement, but I guess I would start with just selecting all from Pokemon app, Pokemon, join.
Okay. So we'll start with the Pokemon. And we execute this query, we can see, okay, so we have an actual Pokemon there, but we want to get all of its moves. And we can't directly go from a Pokemon to its moves because we have this intermediary table. So we now have to join on that intermediary table. So I'm going to call this P. So we're going to join this Pokemon moves. We'll call it PM on p.id equals pm.pokemon ID. And we also need to join this the actual move table. I'll call it M on pm.move ID equals m.id. So this is kind of ugly to look at in the terminal, but here we have both of these. You can see we have two moves here. So I'm gonna make this a little easier to read by just selecting everything from moves. So m dot. So here are the 2 moves that we have. So we got the same thing. Again, we have this 2 join tables, blah, 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 blah. So using the Django ORM, it's a little easier. We just do Pokemon1.moves.all, and we get this. Here we have to, do this whole query, but same result, right? Okay. But so we know we can go from Pokemon to moves, but it's not obvious, looking at the code, that we can go from move to Pokemon. But you can actually. So you can go move. Actually, we'll do move 1, this particular instance. So move 1, right? We have it right there. So move 1 dot, and then we can't just do Pokemon. It would be nice if we could. That doesn't work. But what we can do is Pokemon underscore set, which is just something you have to figure out from looking at the documentation. So this is how Django does it by default. The reverse relationship that isn't explicit in your code, you have the model name underscore set. So if we do move 1 dot Pokemon underscore set dot all, we get the Pokemon, or all of the Pokemon. In this case, it's just one, but all of the Pokemon that are associated with this one move. So again, there's this trade-off between if you write the raw SQL, it's obvious, right? It's obvious what it's doing, and it's the same everywhere. If you're using an ORM, you get some conveniences like, you know, just a few characters to get this, whereas you got to write a whole SQL statement. But here, like, this is kind of quirky. It's simple, right? It's simple, but it's not obvious why that would be, or you know, that you could do that. So yeah. That's yeah. Questions.
When you go into this Python like little terminal thing and you assign, so like when you made Pokemon 1 equals and then move 1 equals, that's only, those variables only last while you're in this, right? If you exit and then go back into it, those variables are kind of pretty much gone, right?
Yes, exactly.
And they don't show up anywhere else. Like I was like, obviously not going to show up in the database, so you can kind of just, okay, so they're just,
Well, they actually do show up in the database. So anything that we do here is actually going to show up in the database, and because this database is attached to a volume, that's going to persist.
sorry, I
So
meant like the Pokemon 1 and move 1, like whatever you name, whatever you,
the Python variables are all going to disappear when I exit the shell, but the actions that I've taken do actually, you know, do stuff in the database.
yeah, okay.
Okay. Are there any questions? And again, this is all stuff that you would have to look up in the underscore set. For example, so the example they have is publication and articles. So if we look up here, publication, there's no way to go from article to publication. So article has a publications field. So we can do article.publications.all. So that works. But the reverse relationship, again, not obvious how you could get there using this code. So from publication, if you want to get to all the articles, you have to do this article.set. So publication.article underscore set. So for better or worse, that's just how it is, and you'd have to look stuff up in the documentation. But you know, if you have a basic understanding for what's happening and what you want to do, it makes it much easier, because now you're just trying to like find the right syntax or whatever to do what you want to do. All right. So that is pretty much it. Are there any questions about that?